Yeah, let's move on to the last property, which is duality property. So this fellow actually deals with, okay, so this fellow will write down the property, but what this fellow will do is this fellow will deals with what Fourier transform of Fourier transform of x of t means what? If you take Fourier transform of a signal two times, what will happen? So that we call it as duality property. So let us write down that let x of t has x of j omega as the Fourier transform. Now what we do, you replace omega with t, so you will get a function which is in time domain, right? So if you replace omega with t, you get a function in time domain, and if you take Fourier transform of that signal, you will get 2 pi into x of minus omega as the Fourier transform. So if you take Fourier transform of a signal, you get x of j omega, and you replace omega with t, you get a time domain signal, and again if you take Fourier transform, you get 2 pi times x of minus omega. Means what? The Fourier transform of a signal will be closely related to x of t. Means what? In x of t, you replace t with minus omega, you get the Fourier transform of x of jt. Okay, so let us prove this result first and then take multiple examples. Okay, yes, so how do we prove that? So we know that Fourier transform of x of t is given by x of j omega, which is equal to integral minus infinity to infinity x of t e power minus j omega t dt. So this is our analysis equation. So instead of omega, if you put lambda, nothing is going to change because that is a dummy variable. Okay, so what do I mean by that? So this is same as, okay, x of j lambda is equal to integral minus infinity to infinity. Doesn't change, only thing is that omega is replaced with lambda, correct? X of j lambda is equal to integral minus infinity to infinity x of t power minus j lambda t dt. Still this is Fourier transform of x of t, but only thing what changes, the variable changes. Instead of using omega, we are using lambda. So just for clarity purpose, now we take Fourier transform of this guy x of j lambda. Okay, so what will happen? Okay, so taking Fourier transform, okay, so taking CTFT of x of j lambda, so what do we get? Let us call that to be some x1 of j omega. Okay, so x1 of j omega would be equal to integral minus infinity to infinity x of j lambda e power minus j lambda omega d lambda. Correct? Why? Because we are taking Fourier transform of whom? X of j lambda. Okay, so this should be equal to how much? Note that I repeat here, what is that we have done? We took first Fourier transform of x of t, and then we are finding the Fourier transform of x of j lambda, which is Fourier transform of x of t. Means we are taking Fourier transform of x of t twice. Okay, so this should be equal to how much? So let us replace x of j lambda. So you get integral minus infinity to infinity x of j lambda is integral minus infinity to infinity x of t e power minus j lambda t dt, and this fellow is multiplied with e power minus j lambda omega d lambda. Okay, so what we will do, we will bring the common terms together. So this should be equal to, first we'll integrate with respect to, let us say lambda. What will happen? So integral minus infinity to infinity. So integration with respect to t we will do later, and hence we'll bring x of t out. Now let us integrate with respect to lambda. You will get integral minus infinity to infinity e power minus lambda times t plus omega j is there, correct? So e power minus j lambda, I took it out. So you will get t plus omega d lambda, and later we do integration with respect to t. Now look at the term inside the square bracket. So this is similar to what? It is nothing but Fourier transform of 1. Okay, but omega is replaced with t plus omega, so definitely that should be equal to how much? The term inside the square bracket would be Fourier transform of 1, but omega replaced with what? T plus omega. So what do we get? We get 2 pi. What is Fourier transform of 1 here? 2 pi delta of omega. Instead of omega we have t plus omega dt. Okay, so this 2 pi is a constant, we will keep it out. So we get integral minus infinity to infinity x of t delta of t plus omega dt. So clearly this would be equal to how much? This is definition of Dirac delta function. This is looking like integral minus infinity to infinity x of t delta of t minus t naught dt. But what is t naught? Minus omega. So that should be equal to x of t naught, which is minus omega. So that would be the Fourier transform of which signal x of which function? X of j lambda. So what is that we have done here? We took Fourier transform of x of t and we called it x of j lambda, and if you take Fourier transform of that, you get how much? 2 pi times x of minus omega. So lambda and t are dummy variable, and hence we can say x of jt will have what as Fourier transform? 2 pi times x of minus omega. Okay.